Yeah. Do what? Yeah, that's always fun. Okay, so let's do another exponential growth problem. You ready? Ready? Yeah? Okay. Alright, city P. City P has a population of 20,000 in the year 2005. So we're going to use that as our starting point. Okay? So I'm going to say 0 and then population of 20,000. Population of city P always increases by 11% every starting 4 years. So right there, you should be able to make an equation. Yes, it's y equals 20,000 times 1.11. Okay? Because the 0.11 is for 11%, and then you have to have a 1 because the population is increasing. So the what? Zero. How do you feel about that? Okay, sorry. Okay, city Q. City Q's population doubles in 2/3 of the time that city P's population doubles. Okay? So we need to figure out how long it takes for city P's population to double. How do you do that? Okay, good. So what Mackenzie's doing is she's saving a step because if it's starting with 20,000 for it to double there, it has to be 40,000, right? So you make this equal to 40,000. But your first step in solving would be to divide by 20,000, you're going to get 2. So she says just go 2 equals 1.11 to the P over 24 power and solve that for P. So how do you solve that for P? Natural log both sides. That will work, yeah. You'll have to use the natural log eventually. Okay, so the natural log, let's just move the exponent in front. So how do you solve that for P? Divide by what? Yeah, so natural log of P divided by natural log of 1.1 first. And then we'll divide by 24. Okay, so go ahead and do that and show me what you get. Because we want to know how long it takes for the population to double. 2 is double. What is it? Oh, I got the rock.
I got 159.
So we get 3 different answers?
I got 159.
Hold on, I got 159. Okay. So, okay, so you guys went natural log of 2 divided by natural log of 1.11. And then you take that and go times 24. Okay, so it takes about 159. Okay, we're going to round in a minute because what we need to know is how long it'll take city P's population to double. It doubles in 2/3 of the time that city P's population does. So I need to take this and figure out what 2/3 of it is. So times 2/3. So I'm going to say they double in about 106 years. Okay? Sound good? Okay? Alright. So now that we know that, we can write an equation for city Q. Oh, no, we don't know how many people started up yet. Okay, so we know it doubles. Yeah. Doubles in what do we come up with? 106? Okay, boy, this is a pain. In the year 2010, city Q has 90% as many people as city P. So we gotta figure out how many people city P has in 2010, right? So how do you do that? How do you figure out how many people city P has in 2010? Okay, so you get 5 into that equation, so do that. Yeah, 2 plus 5 in here for B, so it's 5 years after 2005. 2010, so that's 5 years. City Q has 90% of this, so that's 90% of 4 times. I blame Cameron for that. We're only thinking all of this. Like the thing here. How many? 300 and what? 396? Okay, so can we use that to come up with an equation for city Q? Y equals A times 2 to the, yep, to the P over 106. Okay, yep, excellent. You see what she's got going there? And then you plug in 5 for T and plug in this number right here for Y and plug in X. Did you have a question? Oh, okay. Alright, so if we go 18396 equals A times T to the 5 over 106. You can figure out what T to the 5 over 106 is, right? 18396. Yeah, we're going whole numbers here. So what, no, but what is this? What's T?
It's 1.3.
It's what?
1.3.
Give me a couple more. This is going to focus on this. Okay, so that's probably good. So good old few decimals there. So that's what makes a big difference. Yeah, and then divide by that. So A equals. That's what you get with that. You can look at the difference. What? 17,804. Okay, so that's for city Q. So what'd you say? So Y equals 17,805 times 2 to the P over 106 is the equation for city Q. A lot of work, yeah. But yeah, now we're basically. Right. So in the year 2027, what will be the population of city Q? So now that's an easy question to answer. Yeah. So you just plug in what? 1P2 plus T. So what do you get for the answer? $20,558. Not what you got? So yeah, those are a lot of work. They make those really complicated. You get the what? You get this one right here? Well, it says that it doubles in 2/3 of the time that city Q's population doubles, so that just tells me I need to figure out how long it takes for city Q's population to double. Alright, next one, back to the pulleys. Woo. Ready? This is like a nightmare. Alright, it says assume pulleys A and B are rigidly attached to the same axle, which means that their angular velocity is going to be the same, right? Pulley A has a radius of 3 centimeters, pulley C, this is 3. Pulley C has a radius of 4 and is turning at 325 RPM. So that's a good clue because you know there's a relationship between those things. Pulley B has a radius of 6. If pulley B has an angular speed of 150 radians per minute, what is the radius of pulley B? Yeah, so we need to take the angular speed and do what with it first? convert it to RPM, yeah. So I think this one's gonna be with it. So if we go 150 radians per minute, and we wanna change that into RPM, we're already into it, so it's a pretty easy conversion. What do you have to do? Divide by 2 pi, very good. One revolution is 2 pi radians, and the radians cancel. So what do you get for that? Huh? What do you get? 235? 235 RPM. Okay, and now everybody's connected, so it's a fun little game from here. If this one has a radius twice as big as this one, well, how's the rate RPMs of this one going to compare to that one?
Yeah, that's 23.8.
So it's 23.8, not 235? I guess that makes sense because we less than 150.
Yeah, that's
23.8 RPM. Okay. Anyway, if this one is twice as big as this, and they're connected by a pulley, how are the RPMs of this going to compare to the RPMs of this? This one's going to be twice as much. And this is going twice as fast as this little guy's got to go really fast to keep up with the big guy. So twice 23.8 is what? 47.7? 47.6, okay. Yeah, that means that since these are on the same rigid axle, this one is also turning at 47.7 RPM. Alright? And so if this is turning at 47.7 RPM, how many times faster is this than this? Yeah, divide 345 by 47.8. 6 times? 7 times faster? 6.8? Okay, so that means this radius has to be how many times bigger than this one? 7 by 6.8 or whatever, so the radius of B is what? Would be like the inverse proportion, so you go this over this equals this over this. So 325 equals, then you have to flip them so that this is the inverse relationship. So it's B over 27. So what do you get from that? Okay. Well, that's a fun one. That sort of encapsulates all the understanding about the relationship between the RPMs and the sizes of the things. That's a good one. Yeah, that's a good one. I like that one. How do we get what? 47.7. We give this proportion with these things, so we said 23.8 over x. That's what we're trying to find here. Equals 3 over this. This is the inverse relationship. There we go for small x. Here is x. Goes across in this little, and that the same way you can go farther and farther than you have it now. Okay. Okay, we good there? From here? Okay, well we knew that this one's going 150 radians per minute, and we know that one revolution is 2 pi radians. If you go 150 divided by 2 pi, you get 0.2. Yeah, you have to put it in parentheses or else it ends up dividing by 2 and then multiplying by pi, and that's when you get the 2. Yeah, that's a notice for it. Okay, let's do one more here. Okay, Mr. X prepared to jump across the English Channel. The more he prepared, the further he was able to jump. The length of his jump was a linear function of the number of hours that he prepared. After preparing for 10 hours, he was able to jump 10 feet. After he prepared for 10 more hours, he could jump 20 feet. So does that mean 20 goes with 20? That seems weird to me. After he some more hours, you could jump 25 feet. 230 over. Okay, yeah. If you prepared for a total of 55 hours, how far could Mr. X jump? So this is the linear thing, right? So we're going to take that equation, y equals ax plus b over x plus c. I feel like this is more difficult than when you already know what a is, but you guys have said you like it better when they just give you 3 points. Whatever. Yes. If it's always less. Well, because the top is linear and the bottom is linear, but they do divide. So it's a linear to linear rational function. They are individual. Okay, so we're going to take these points and plug them into that equation and get 3 separate equations, right? Okay, so if you plug 10 into there, you get 10 equals 10a plus b over 10 plus c. Right? If you plug 20 and 20 into there, you get 20 equals 20a plus b over 20 plus c. And if you plug 30 and 25 into there, you get 25 equals 30a plus b over 30 plus c. Okay? Oh, you do want to. Okay, what do you do next? Solve both sides. So 10a plus b equals 100 plus 10c. Down here, 20a plus b equals 400 plus 20c. And for this one, 30a plus b equals 750 plus 25c. Right? Yep. Okay, now what? Okay, good. Get all the A's, B's, and C's together. So this one changes into 10a plus b minus 10c equals 100. This one is 10a plus b minus 20c equals 400. Huh? What did I say? I wrote 20. Wrote all this down. And then this one is 500a plus b minus, you don't find anything, minus 25 c equals 750. Okay. All right, so like Cameron said, matrix. Hey, look. You got it? Look, you have a calculator? Do you know? All right, you ready?
is the keynote.
That's what we're
I mean,
doing.
you know, so I think
Is that what everybody got? Yep. Cameron, no, you look distressed. That should be exactly. You want me to look at it and go make it today? You have to take this, blue pen before you do that. And then you see it. Not to do it. Alright, so, according to your calculator then, A was 40, B was -300, and C was 10. Okay, so the equation is y equals 40x minus 200 over x plus 10. Okay? So if he prepares for a total of 55 hours, how far could Mr. X jump? How do you figure that out? 55 is for X. X equals 55, Y equals 30.77. Okay, then it says in part B, the English Channel is about 110,000 feet across at its narrowest point. With sufficient preparation, could Mr. X jump across it? Obviously not. What's the maximum that he's going to be able to jump? 40. A is the maximum. Sure. So, no. Max equals 10. Okay?